The nth power cancels out the nth root, leaving you the u, which is whatever's under the radical, equal to whatever was on the right raised to the nth power. You don't have to remember all those symbols, but it's good for you to see them anyway. Basically, it's everything I talked about on the I will board. And then it has to specify any integer greater than 2, because if you had 1, the 1 power, that doesn't really change anything. It's uninteresting, and we wouldn't really care. So it's only interesting after 2 and higher. So these are the basic steps for solving a radical equation. First step is the same as every time we've worked with radical equations. You isolate one of the radical terms. Apply the power property. The power property is the thing I just mentioned. You're just raising each side to the power you need to cancel the root. 3, multiply that out. And then if your result still contains a radical, you have to repeat the whole process. And our last example today is going to be like that. Solve for your variable and check for extraneous roots. I'm going to talk more about this in just a moment. This works differently than when we were doing that for rational equations, and I'll explain how. But first, I want to just do this little baby problem. It's like an appetizer. Yes, it's going to warm us up for the rest of the lesson. I was going to keep going with the food analogy, but you're probably thankful I did not. So to isolate the radical, what do I need to do first? Do what to both sides? To get the radical by itself. How will I begin? Well, before that, I have to get the radical alone first. So the first step is to isolate it. Right now it has what on the outside? It has on the radical part. So here's my radical. It's got a divide by 4 on the outside of it. It's got a minus 5 on the outside of it. I have to undo those things. Which one will I undo first? The 5, right? So add 5 to both sides. So that leaves me cube root of 6x minus 7 over 4 equals negative 1. And then what? Times 4. And now I have the cube root of 6x minus 7 equals negative 4. And now the radical is isolated, right? It's all by itself, the radical part. And then the next step is to apply the power you need to cancel the root. In this problem, what power is that? 3. Okay. So raise both sides to the third power. So on the left, the power cancels out the root, leaving you just what's underneath, which is called the radicand, 6x minus 7. Yeah, not the radicand. You beat me to it. I've said that joke before, apparently. Negative 4 cubed, let's talk briefly about odd powers on negative numbers. Negative 4 cubed means negative 4 times itself 3 times. So when you do those first two negative 4s, what does that give you? Positive 16, right? And then when you do times that last negative 4, what will the sign be now? Negative. So you have to be careful with the odd degrees and the negative numbers, what your sign's going to be. So that's negative 64. And then now you just solve. That's just a regular equation, right? So take a minute, solve that equation. It's pretty standard. Q on negative 1, 19 over 2. So either fraction or decimal is fine. Yes? When I was isolating the radical? Yes. Yeah, that's right. So I undid the addition or subtraction first and then the division. All right. So that was our little intro problem, okay? We're going to layer this up a little bit with this problem. The very first step is to isolate your radical. Find the radical. What side is it on? Left or right? Where is it? It's on the left side. Is it all alone on the left side? Or does it have something with it? It has an x. Okay. So in order to isolate it, you have to undo anything that's on the outside of it. And so that plus x is there. So to undo that, we subtract it from both sides. And that leaves me radical 2x plus 31 equals 2 minus x. Y'all know what? Put this problem on hold for just a second. I forgot to, before we do this, I have to tell you about how to check for extraneous. So we'll come back to this in a second, because this one we will need to check for extraneous. I need to explain to you how and why we're about to do what we're about to do. This is the bottom left of your notes, and you have a little bit of blank space under there, and I want you to write the following thing. So I switched gears, I stopped that problem for a second, went back to this slide. This is the bottom left of your notes. It says, be sure to check your solutions in your original equation because you may have extraneous solutions. Please write this. When applying even powers. And I'll explain that. When applying even powers. For rational equations, which we've been doing the last several days, here's how you checked for extraneous. You would have a solution like x equals 7, and you would only need to plug it into the denominators and check if it made any of them 0, right? That's what we were checking for there. But the radicals work differently, okay? We don't have any denominators. What you have to do to check for extraneous is plug it back into the original problem and make sure it checks. Now that sounds a lot like just checking your answer, which I don't generally require you to do. If you're feeling confident, keep your answer, but you can always check it if you wanted to. Let me show you why you only really need to be sure to do it on even powers. And what I'm about to write down, I don't need you to write down. I kind of like just want you to listen while I illustrate this for you. Let's say you have this equation. X minus 2 equals the square root of x. Okay, this is a radical equation, right? There's a radical. This has one solution. Take a minute, guess and check a few numbers, and come up with the solution in your head. If you check 5 or beyond, you've gone too far. So it should only take you a moment to come up with a solution. Who has their answer? Okay. Parker, what'd you come up with? 4. Okay, 4 works. Because if you were to plug it in, 4 minus 2, does that equal the square root of 4? Yes. Okay. So keep this in the back of your head that we already know that there's one solution and it's x equals 4. Now that was an easy problem that we could do in our head. But let's say this was a hard problem, and so we wanted to follow the steps in order to do the math. Here's how that would look. My radical's already isolated, so I would raise both sides to what power here? To get rid of the square root, I would need power of 2. Notice that's an even number. And then on the left-hand side, this means, so x minus 2 quantity squared means x minus 2 times itself. And then on the right-hand side, the power cancels the root, leaving me just x. Okay. More math ensues. On the left, it's x squared minus 2, which is a minus 4x plus 4. Again, you Y'all don't need to be writing this down unless you just want to. I'm just illustrating. I'd really rather you just listen so you're just kind of calm. I'm showing you just why we have the rule up there. And then in order to solve, I would need to move that x over to the left. And I would have this. And then I would factor what multiplies to 4 and adds to negative 5, then you would come up with, if I was letting you, negative 4, negative 1, you would make your factors. And you would solve them, and you would get x equals 4 and x equals 1. Well, we already know which of those is extraneous. The one that's the 1, right? Because we already know the answer is 4. But here's how you would check that and how you'll be checking it in your problems. You take those numbers, you go back to the original equation, not any of the modifications you make in the process of solving, none of those. Go back to the original stuff and plug it in. Now we've already checked 4 and we know that it works. But here's what happens when we check the 1. I put 1 in for the x's, and I get this. Negative 1 equals 1, which is not true. And so 1 is extraneous, it doesn't work. And this anomaly of sorts only comes up when you're raising both sides to an even power, the 2, a 4, or a 6. Yes, if it doesn't check out, it's extraneous. That's exactly right. And then I had some people ask me today, well, but isn't the square root of 1 positive negative 1? And then maybe it does kind of check out. But here's your dose of nerdiness for the day. When the square root's already in the problem, it's indicating just the principal square root or the main square root. It's the same as if I just gave you this square root of 9, you would say, oh, that's 3. The positive and negative only comes in when you're solving a quadratic to represent that there's two different solutions. So here I gave you square root of 9. But if I asked you what are the solutions to this and you introduced the square root as part of the solving process, then you need the positive or negative 3 because plugging both of those into the original would check out and give you 9. So this is called the principal square root. The negative version is the opposite principal square root or the negative principal square root. Okay, it's the opposite of the main one. And so that's why this rule only applies. You really only need to check for extraneous when you're raising it to an even power. Technically, you should always check your answers, but I mean, let's be realistic here. Nobody got time for that. All right, so back to this problem. What power do I need for both sides here? 2, right? So raise both sides to 2. That's even. So eventually, at the end of the problem, we're going to have to check for extraneous solutions because of the even power. So now here's what we've got. On the right-hand side, the power cancels the root. We got 2x plus 31. That part's easy. But on the right-hand side, you have to be careful. It really feels like we just want to put 2 squared minus x squared. I don't want you to miss that. But it's not that, okay? It's not just squaring the 2 and squaring the x. This means 2 minus x times 2 minus x. And so that's a FOIL or box or double distribute, right? So I'm going to give you a few minutes to finish out this problem. And I'll put some hints on the right in case you get stuck. You're going to be foiling the right-hand side. Then you're going to get it everything equal to 0 by moving stuff over. Then you will factor and solve. And then you will check for extraneous because we raised both sides to an even power. So take several moments and do that. have the work up until after the foiling part. So if you're getting weird stuff, check your work with mine that you got 4 minus 4x plus the x squared after you foiled. Then the next thing I told you to do was get it equal to 0. You can always do that one of two ways. You can take everything on the right and move it over, or everything on the left and move it over. I'm moving stuff to the right so I can keep the x squared positive, the positive a value. If you moved everything to the left, your x squared would be negative, which means you would want to divide out a -1 to everything before you factor. So be careful about that. But here's what I'm doing. Minus 2x minus 31 on both sides. So that's nothing equals x squared minus 6x minus 27. And you were factoring that correctly. I came around, I saw your crosses. What multiplies to negative 27 adds to negative 3? You said negative 9 positive 3. Dividing by the a value doesn't change anything. So your factors are x minus 9 times x plus 3. Be careful that you don't give me negative 9 and 3 as answers right here. A lot of people are stopping right here still and giving me the solutions from those numbers. But technically what's going on is you're using them to make factors, which you're setting equal to 0 in solving, which means you're moving it over, which means you're changing the sign, okay, because they're linear factors and there's no other solving to do. Why do we have to check for extraneous in this problem? What was the thing? Matthew? Let's see. That is how we check for extraneous. That is correct. But why am I telling you you must check here in this problem? Even power, right. Anytime you apply an even power in the problem, you have to check for extraneous because it could create double or extraneous solutions. And so here's how you check. Sadly, the checking part's kind of like a whole other math problem on top of the math problem you already did. You have to keep your order of operations straight. You have to remember how radicals work. So checking 9 first. Remember, you go back to the original problem. So I'm going to check 9 by plugging it in for the x's. So here in the first one, that will give me the square root of 18 plus 31. And then plus 9 equals 2. Under the radical, that's 49. And then that's 7. And that's not checking out. So 9 is extraneous. Checking negative 3 looks like this. Under the radical, that gives me negative 6 plus 31. Plus x means minus 3, because it's a negative number. That's the square root of 25 minus 3 equals 2. Or 5 minus 3 equals 2, which checks. So x equals negative 3 is the only solution. And x equals 9 is extraneous. Does anybody need this slide up anymore? Does anybody need stuff from the bottom to slide down? Do I need to slide the slide? You all feel good? Okay, we got one more problem to do. Deep breaths. Focus and center. Here we go. How much time we got? We are out of here at 20:25. Okay. Very first step is to isolate the radical. How many radicals do you see here? 2. So we're going to do the steps. It's going to eliminate one radical, and then we have to do the steps over. All right, so that's how the process is going to go. One radical is already isolated, that one on the left, so we don't have to move anything around. We can just get started. Okay. So what do I need to raise both sides to get rid of that radical? What number? 2, okay. Is that even or odd? Are we going to have to check for extraneous roots? Yes, we are going to have to do that. So raise both sides to the 2. And then here's what we have next. On the left, just 3x. On the right, we have this times itself. And you can see how that's going to get real ugly real fast. But we can handle it. So that stuff on the right is a FOIL. But in the process of foiling that out, we're going to talk about multiplying radicals, adding radicals, and multiplying radicals by a constant. So we're going to review some stuff. But let's begin just sort of with the first thing. First things first. FOIL is the first terms. So I'm going to take this term times that term. Well, that is radical x minus 3 times radical x minus 3. Here's another way of thinking about that. Isn't that the same as radical x minus 3 squared? True, right? Well, what does that square do to the root? It cancels it. So it's really just going to be x minus 3. So right here, when I do the first term times the first term, the radicals drop off, leaving me just x minus 3. So that's the F part of the FOIL right there. Here's the O part. The outside terms, radical x minus 3 times 3. You're just mushing those together. It's the same thing as instead of 3 times some crazy radical, if I had 3 times something easier, like if I had 3 times x, what do you do with those two things? You just write it like this. You just mush them together. Same thing with the radicals. 3 times radical x minus 3 is just mushed. 3 radical x minus 3. Okay. So the outside terms just give me this. The inside terms give me the same thing. Because it's the same numbers. Right? These are my inside terms, 3 times radical x minus 3. And the L part is the easiest part. The last terms are 3 and 3. What is 3 times 3? 9. That's easy. Questions so far about the radical stuff? All right. So now we can look at that right side and start cleaning it up by combining like terms. There are no like terms for the x. There's nothing here with just a simple x on it. So that's just going to come down. The negative 3 can combine with the 9. That's way over here. And that makes 6. But when we go to combine those radicals, the reason we can combine them is because the radical pieces are exactly the same. When you're adding radicals, the radicands do not change at all. You're just doing the math on the coefficients. So you're basically saying, okay, I have 3 radical x minus 3s, and I'm adding 3 more. How many of those do I have altogether? 6. I have 6 radical x minus 3s. And that's when you're adding or subtracting radicals. And that's all fine and good. But do we still have a radical in our equation? Yes. So we have to go all the way back to step 1, which begins isolate the radical term. So here's your radical term, 6 radical x minus 3. We need to move this x and this 6 over by doing the opposite to both sides. So on the left, that's 2x minus 6. And on the right is 6 radical x minus 3. And here I'm going to bend the rules a little bit. I know that can be frustrating sometimes. You want to be like, Ms. F, you told us the thing, and then you changed it, and now I'm confused. But I think you'll forgive me a little bit when I explain why. Technically, we should be dividing by 6 here. Technically. But if you think about it for a second, on the left-hand side, if I divide both of those things by 6, that's fine here when it is 6. But what's 2 divided by 6? It would give me a fraction, right? And then, what would I do in the very next step to try and get rid of this radical? Let's square it. Well, I don't really want to be squaring the left-hand side if there's a fraction in there, because it will end up being a FOIL with a fraction, and I don't really want to do that. So I'm bending the math rules a little bit to make the numbers easier to work with. We're going to just skip straight to the squaring part and not do the divide by 6 part. Okay? To keep our math simple. And here's how that would look. Or to keep our math simpler, I should say. So I'm skipping to this part here. So on the left, again, you have to recognize it's a FOIL. X minus 6 times itself. And then on the right, you have 6 radical x minus 3 times 6 radical x minus 3. So the 6 times 6 part is 36. And the radical x minus 3 squared, the radical drops off. And you're just left with the x minus 3. So I'm going to give you a few moments to wrestle with the rest of this problem. You will begin by foiling the left, distribute on the right, you will get it equal to 0 so that you can factor and solve, and then you will check for extraneous. So take a few minutes and do that. And I have these steps up here to help you out. On the right gives you 36x minus 108, right? The numbers look a little bit weird, but it gets better in a minute. You move the stuff on the right over by doing the opposite. So minus 36 plus 108. Math gives you 4x squared minus 48x plus 144. Thank you. Before you start factoring here, factor out a GCF. What's the GCF? 4. So x squared minus 12x plus 36. Now, I have people ask me today, well, what do we do with the 4? Well, just divide it out. You only have to remember it when there's an x there. But since it's just a constant, really you can just divide it off. And it doesn't you don't lose a solution because there's no variable. Then you factor what multiplies to 36 and adds to negative 12. No. Hold on. I'm tired and I'm mixing up the problems. 1 second. And I'm trying to rush because I'm sure your brains are fried. What multiplies to 36 and adds to negative 12? I don't know. What does? Am I doing something wrong? But I did something wrong. It should not be that. There? Thank you. Right there. Thank you. This is 60. I'm good. Okay. This is 60. All right. No, because I divided out of 4. Sorry. It's 15. Now it's negative 12 and negative 3. Okay. So that's going to give you this. I'm going to spare you the suspense. These check out.